Good afternoon, everybody. This is Mr. Williams, and this video topic for this little mini lesson is on unit conversions. And the focus of this mini lesson is to discuss the conversion problems that are used in the metric system, and it is imperative that a student has prior knowledge of the metric system and the relative values of those prefixes. So if you are unaware of, for example, mega or milli or centi or kilo and what those values would mean, you need to refer to the chart that was given to you in class or that's in your textbook to discuss those. What I want to look at today is I want to look at 4 different examples of unit conversions. The first one is what we consider a one-step conversion, and we're going to convert 4,500 kilometers to meters. And in this case, what you want to notice is that one thing we're looking at a unit with a prefix compared to a base unit, which would be meters, just M. Anytime a base unit is involved in a unit conversion is going to be a one-step problem. And so when we write this out, we're going to start with our given, which is the 4,500 kilometers. And when we start with that, what we are going to do is we are then going to convert and make our conversion factor. Now, since kilometers, if you want, you can put it over 1, and kilometers will be in our numerator. Therefore, kilometers must go in our denominator of the following conversion factor so that we can then take and cancel out those units. And so now we'll put meters on top, and what you have to ask yourself is which one is bigger. And in this case we know that kilometers is bigger, so it gets the value of 1, and the unit meter, there are 1,000 meters in a kilometer because kilo means 1,000. And when you process this conversion factor, you would get an answer of 4,500,000 meters. And it should make sense because we have a smaller unit in meters than what we started with for kilometers, and our answer should get bigger. If we move on to the second example, this is what we consider a two-step metric conversion. And what I'd like to do in this one is I want to convert 23.5 megaliters to milliliters. And what you will notice is that there is not a base unit in this conversion. And when that is not the case, the prefixes, the values that you memorize, do not mean the same if you tried to go all the way from megaliters to milliliters in one step. So what we want to do is we want to go back to the base unit and then use that value to go to the secondary unit so that our prefixes and the values of them that are associated with those units make sense. For example, we would have 23.5 megaliters, and again, if you want, you can put that over 1 if that makes it easier. And now megaliters is in our numerator. We're going to have to put megaliters in the denominator. What you will notice is that I'm always putting the unit first before putting in the numeric value because we want to make sure that our units cancel out before we even worry about what the numbers are that go with them. Now, megaliters, we want to convert it to liters first because that's the unit where we know how much a megaliter is worth. Since megaliters is bigger, that will get the value of 1. And now we're going to know that there's 1 million liters in a megaliter. Megaliters cancel. That does not get us to where our final answer needs to be, though. Our final answer must be in milliliters, so we're going to go with another step. Since liters is in our numerator, that makes liters have to go in our denominator of the following conversion factor. Milliliters will go on top, and we know 1 liter, there are 1,000 milliliters. And so when we do the multiplication, again, liters will cancel, we'll be left with milliliters, and you get a value of 2.3 times 10 to the 10th milliliter when you solve that question. Again, what you want to notice here is that we have megaliters canceling in each case, we have liters canceling, and we've done 2 steps to do this conversion because our base unit was not in the actual conversion question to begin with. If we look at our third example is looking at multi-unit conversions. And what do we mean by that? Meaning that the number that we're converting has at least 2 units in it. For example, we have 41.5 liters per every 1 hour. This could be maybe how much gas is being used up in an engine, or we're looking at some specific unit over time. A lot of the times we think of velocity in like meters per second. We could measure something like that as well. In this case, we're looking at 41.5 liters in an hour. But we want to convert it to milliliters per second. And what you notice is that both liters and hours have to change in this problem. Now, it doesn't make a difference which one you change first, but you want to make sure you're consistent with where you put your units. If you notice, it's extremely important that I placed hours on the bottom because it's per hour, per 1 hour. The 1 might not show up in the actual unit, but we know the 1 is there. So when we go to convert, let's first convert liters, because liters to milliliters, there's a base unit in it. We know it's a one-step problem. And so since liters is in our numerator, liters would have to go in the denominator, and we're going to put milliliters on top. 1 liter is bigger. There are 1,000 milliliters in that 1 liter. And if you notice, we would now have liters cancel, and our unit would be milliliters per hour if we were to stop our problem right now. But we need to continue on. And so now what we're going to do is we need to convert hours. And this is the trickier part. Since hours is in the denominator, we must put hours in the numerator again so that it will cancel. And if you notice, I once again put my unit in first before I'm putting any numbers in to this conversion factor. The question you have to ask yourself is, what do I know converts to an hour? I know minutes convert to an hour, and I know that in 1 hour there are 60 minutes. Hours will cancel, and if we were to stop our problem, we'd be at milliliters per minute. We want to keep going though. We're not done with that yet. So we need minutes to go in our numerator, and seconds will go in our denominator. Minutes will cancel, and we know that in 1 minute there are 60 seconds. What you will notice this time is that you will have to both multiply and divide to get the answer that you are looking for as you go through this one. 41.5 liters times 1,000 milliliters divided by 60 minutes divided by 60 seconds. And when you do that, you get an answer of 11.5 milliliters per second. I would suggest that you try that problem on your calculator just to make sure that you agree with my answer as we're going forward. The fourth type of conversion that we want to look at is converting squared or cubic units. The misconception is, since we're going from meters squared to centimeters squared in the problem, is that we only have to multiply by 100. Since it is a squared unit, that is not the case. What I always suggest doing in this instance is that we're going to again start with our given, the 2.5 meters squared. And once again, if you need to write it over 1, you can do that so that you know meters has to go in our denominator. And I would totally agree that 1 meter is 100 centimeters. But what you will notice is that in our numerator, meters squared is really meters times meters. That's what that is equal to. And so when I write 1 meter in my denominator, it only cancels with one of the 2 meters in the meter squared problem. So I have to actually create a second conversion factor of 1 meter is 100 centimeters. And what that will do is cancel out with the second meter. And when you take centimeters times centimeters, you're going to get a centimeters squared answer. And what you notice is, if you have a squared unit, you're going to have to do 2 conversion factors to do this problem. And when we do that, you're going to get an answer of 25,000 centimeters squared. If it happened to be a cube unit, instead of doing it twice, you would have to do the process 3 times. I hope this little mini lesson helps you out. What I have on the next slide here is I have some examples and some practice problems I'd like you to try. In each case, there's one of each of the 4 different styles of questions. So try these out. I'm going to actually wait for 5 seconds after I am done talking, and then I will put up the answer so you can check your work. If you have any questions, please talk to me in class. Have a great evening, and I hope this helps you out on your unit conversions.